The next two problems are applications. When we look at number 5, we have a framing store, and it gives you the cost function C of A equals 0.5 square roots of A plus 0.2, and that's how they determine the cost in dollars for glass for a picture frame with an area of A in square inches. The store charges $6 additional if they're going to install the glass. So if we want to write the function D, that's the total cost of piece of glass including installation, and then we'll use it to estimate if we had a picture with an area of 192 square inches. So we certainly know that we will be taking, when we look at D of A, that's just our original cost function, C of A, plus an additional $6. So, we could also look at that as just our 0.5 square roots of A plus 6.2. So when we want to look at our specific application for a glass with an area of 192 square inches, then that's what we put in for our A value. So we know that that is 0.5 times the square root of 192 plus 6.2. And that gives us a cost of approximately $13.13, and that is for a 192 square inch piece of glass, and that includes the installation. Okay, I'd like you to look at number 6 and try to set that up, and pause this while you do that, and then we'll take a look at the solution. When we look at number 6, we can see the g of x is 3/5 times f of x because they tell us that we have a vertical compression of 3/5, and that will be times f of x, which is the square root of 64 times x. So when we substitute in 45 for x, because we want to know after a bounce of 45 feet what will happen, then we have 3/5 times the square root of 64 times 45, which gives us about 32. So that tells us that the rover will hit a downward velocity of about 32 feet per second at the end of its bounce. With number 7, we have 3 graphs of inequalities, and we graph a radical inequality exactly as we've graphed all the other inequalities. We have to decide if it's a solid or a dashed curve or line that separates the segments, and then you have to determine which direction to shade. And you can do that by picking a test point to validate your decision. So I'd like you to stop this now so that you can try graphing these. You graph it just as if we had an equation, but then we shade the appropriate direction and decide whether or not we need the dashed or the solid line. When we look at number 7a, y is greater than 2 square roots of x minus 3, we can first plot a few points. We can see that we've got a stretch by a factor of 2, and then it shifts down by 3 units. And because it's greater than but not equal to that, we want the dashed line for that curve. And then when we want all y values that are greater than that curve, so we shade everything above it. And we do not shade, because we know that all real values, x has to be greater than or equal to 0, so we do not shade past the y-axis. And then certainly it's always worthwhile checking a point using the origin. The 0, 0 should be part of my solution set, so if I put 0 in, I've got -3 is less than 0, which is true. So let's go look at B and C next. When we look at B, y is less than 2 times square root of x plus 3, we can see that it shifts up by 3 units. It is stretched by a factor of 2, and we want all y values that are less than that curve. So it should look like this. And then when we look at C, we can see that it's a solid line because it's greater than or equal to the cube root function. So when we put in our values, it's going to be the cube root function, but it's going to be shifted to the right by 3 units. So, and we're going to shade everything above that. So you can now move on and try the homework.